Hey everyone, so this is the last thing that I want to talk about with this first aspect of the unit of momentum, which is about the graphs. Now, like with everything, you really do want to know how to, uh, you want to know what information you can get from the graphs. Again, it's a big thing and it usually can be found by using the equations. Now, obviously, I've mentioned before that you could attempt to just memorize what you get from taking the slope, taking the area, or just reading the graph for each and every different combination that you might find, but that would end up requiring you to remember probably thousands of different graphs. So your best bet is to just constantly utilize the equations as a way to figure out what you can get from those graphs. So the first graph that we want to look at is the force versus time graph. Now, as I mentioned in previous videos, the thing that you want to remember is when you have a graph, there are three choices. Read the graph, slope the graph, area the graph. Typically, reading the graph is usually just like looking at the x and y values and just saying that's what I can get from it. For example, if I read this graph right now, I'd be getting force. Change of force, whatever it is, that's what I'm getting. Or I could get time. That's it. Now, so usually the reading graph isn't anything important. Usually it's finding the slope or finding the area. Now, the way I usually remind people is to remember the core calculation that you do when you do slope and area. For slope, when you actually go to calculate the slope, what you're going to end up doing is dividing the y-axis divided by the x-axis, change in y over change in x. So slope is division. When you do area, you end up doing length times width or something like that. Basically, it's something times something. So you're going to end up multiplying the x and y values. So the question is, if I look at an equation that has force and time in it, what equation has force divided by time? That would be slope, or force multiplied by time, which is area. Well, in this unit, there's only one equation that has force and time in it, and that is the impulse equation. Because impulse is force times time, that tells me that if I do the area of this graph, then the information I'm going to get from it is either impulse or change in momentum. So a good question could be, between time t equals 3 seconds to time t equals 5 seconds, what is the impulse on the system? And what you would do is find that information by doing the area between those two times. All right. So again, notice how I use the equation to figure out whether I'm going to do slope or area. The equation has force multiplied by time. Area deals with multiplication. Therefore, area gets impulse. All right. Now here's the next question. What if we have momentum versus time? What can we find and how do we find it? Well, if we go through the same process, I can either slope is division and area would be multiplication. If I think about the equation that has momentum and time, the only one that really pops into mind is, once again, the impulse equation. But because the momentum and time are on the same sides, what I want to do is actually move this over, and I can see that because I'm dividing these two things, this would be a slope. So slope equals force. If I take the slope of this line, then I will get the force acting on the system. Now that's not the only thing that I can get from this though. Like I said, normally this isn't something that I would have to mention, but for this specific unit, it actually is worth noting. See, if I try to look at area, you should obviously see that there's no equation that has momentum times time. So area is not really anything. So my only other option would be, what would happen if I read the graph? Now, if I look back to what I had before when I had force versus time, I said that if you read the graph, you would find change in force. That isn't really super noticeable or like noteworthy. I should have said it's not noteworthy because that's fairly easy to tell. If I give you any graph and then I want the change of whatever's on the y-axis, it's easy to see how to get that. If I give you a velocity versus time graph and I say the change in the velocity, it's easy to see that you're just going to take two velocities and subtract them. But with momentum, the way that I can kind of add a little bit of a trick to it is to ask, what is the impulse? If I ask what the impulse is, you may not necessarily know how to get it from here. You might think and confuse it with the force versus time graph, where impulse was found using the area. But if you remember that impulse is a change in momentum, it's the scientific way of saying it, then that leads you into realizing, oh, if I read this graph, if I take the difference between these 2 points, that would get me the impulse. So this is actually the only reason why I'm mentioning it, is because unlike the other stuff, there's no fancy word for change in force or fancy word for change in velocity, change in acceleration. That's just what it is. But for change in momentum, it has that alternate uh, name or term of impulse. So I just want to remind you that impulse is a change in momentum. That if you have a momentum graph, it is going to be super common that they're going to ask, what's the impulse of this? And you have to remember that you get it from reading the graph. You don't take the slope, you don't take the area. It's just find the 2 points that they mention and take the difference. All right. And that's pretty much it. Like I said, you really do need to know how graphs work. You need to know how you can get information from each of the different graphs. While it might be easy just to memorize it because there's only 3 graphs here, just remember that I have tons of different graphs that I can pull out of thin air. Maybe I have an impulse versus time graph, or maybe I do something else crazy like a change in velocity versus time graph or something. You want to know how you can get all this information by using the graph, using the equation, sorry, and thinking to yourself, what would happen if I take the slope? What would I happen to take the area? What equations have the two things multiplied and what has two things divided? All right. If you have any questions, just let me know. Otherwise, good luck. Have a great day.